Object. In the study of light, the term object has a special meaning. It refers as anything which gives out light. Anything which gives out light rays, either its own light or reflected by it, is called an object. Can be a bulb, our face, a tree, or anything. And now come to the term image. In physics, image is an optical appearance produced. It's an optical appearance produced when light rays coming from an object are reflected from a mirror or refracted through a lens. Thus, when we look into a mirror, we see the image of our face in it. In this case, our face is the object and what we see in the mirror is the image. The image of our face appears to be situated behind the mirror. While watching a movie in a cinema hall, we can see the images of the actors on the cinema screen. So, we can say that an image is formed when the light rays coming from the object meet at a point after reflection from a mirror or refraction through a lens. The images are of two types. One is real image and another is virtual image. Can be said as unreal image. The image which can be obtained on a screen is called real image. The image which can be obtained on a screen is called, or formed on a screen is called, real image. So the images formed on a cinema screen is an example of real image. The real image is formed when the light rays coming from an object actually meet at a point after reflection from a mirror or refraction through a lens. The image which cannot be obtained on a screen is called virtual image. The image which cannot be obtained on a screen is called a virtual image, or it's known as unreal image. A concave mirror or convex lens give real images. The image which cannot be obtained on a screen is known as virtual image. Can be seen only by looking into a mirror or lens. It can be said as it's an illusion. Plane mirror or concave lens gives a virtual image. Now we will check how an image is formed in a plane mirror. Consider an object O placed in front of a mirror M'. The object O gives out light rays in all directions. But we need only two rays of light to locate the image. Now a ray of light OA coming from the object O is incident on the plane mirror at the point A, and it gets reflected in the direction AX according to the law of reflection, making an angle of reflection R1 here, and which is having the same measurement as the angle of incidence also, I1. Another ray of light OB is hitting on the mirror at the point B, forming an angle of incidence I2 and an angle of reflection R2, and it is going towards BY direction. The two reflected rays AX and BY are diverging from one another. So they cannot meet on this side or left side. Let us produce the reflected rays AX and BY backwards as shown in this figure with dotted lines. They meet at a point I behind the mirror. Now, when the reflected rays AX and BY enter the eye of a person at a position E here, the eye sees the rays of the light in the straight line direction in which the reflected rays enter it. So the person looking into the mirror from the position E sees the reflected rays as if they are coming from the point I behind the mirror, because I is the point of intersection of the reflected rays when produced backwards to this side. Thus the point I is the image of the object formed by the plane mirror. The image formed by the plane mirror can be seen only by looking into the mirror. So if a screen is placed at the position I, no image would be formed on it, because the light rays do not actually pass through the point I. They appear to do so. The image of this type, which cannot be received on the screen, is known as a virtual image. Now, let us refer an image of an extended object. Image of an extended object. Take this object AB, which is placed in front of the plane mirror MM dash like before. In order to locate the object image of the arrow type object AB in the plane mirror, we will first find out the positions of the images of its toe point A and toe point B here. And it is done as follows, done as like this. From the point A, we draw an incident ray AC perpendicular to the mirror like this. This will be reflected back on the same path because the angle of incidence is 0. So CA is the first reflected ray. We now draw another incident ray AD, which strikes at the mirror at the point D here. The ray AD is reflected along DE, making the angle of reflection R1 equal to the angle of incidence I1. Thus DE is the second reflected ray. When we produce the two reflected rays CA and DE backwards with the dotted lines like this to meet at a point A dash. So A dash is the virtual image of the toe point A of the object. Like this, from the point B, when we draw an incident ray BF towards the mirror and hitting at F, and it is reflected back like the AC, it is reflecting in the same